Hello and welcome. I'm George Lennis with Eberspaecher Climate Control Systems. This webinar video is on the second generation Airtronic 2 heater. This will be a basic level training and will cover the new features, specifications, parts, operation, and service recommendations. The second generation Airtronic 2 heater has many new features. It has a newly designed ECU with CAN, LIN, and S Plus interfaces and a built-in high-altitude sensor. The heat exchanger is a carryover concept, but modified partially to accommodate the new style combination sensor. The combustion chamber is the exact same part as that of the first generation Airtronic heater. The fuel metering pump is of a newer design, with the electrical connector located on the inlet side. Internally, the fuel pump has been modified to make it quieter, including dimensional and material changes. The Airtronic 2 heater comes with a brushless electric motor, which allows stageless heat output, reduced noise levels, and an increased service life. The multi-component materials of the blower fan helps to make the Airtronic 2 heater even more quieter. The specifications of the new Airtronic 2 as compared to the first generation heater. The heating capacities are identical, and the maximum heat outputs are the same as the previous generation heaters. The control of the heat output is now stageless, compared to the 4-step fixed heat output of the first generation heater. This enables a better control of the optimum temperature in the application. The electric motor is brushless and has an extended service life of 5,000 hours, which is more than the 3,000 hours for the first generation heater. The second generation Airtronic heater has a built-in high-altitude sensor, which enables automatic heater operation up to 3,000 meters or about 10,000 feet. The previous generation Airtronic had a maximum limit of 1,500 meters for automatic heater operation. The overall dimensional size of the second generation Airtronic heater is exactly the same as the previous version of the heater. This makes it easier to replace a first generation Airtronic heater with the newer Airtronic 2 heater that will fit in place. As mentioned, with the design changes, the Airtronic 2 heater is a whole lot quieter than its predecessor. The electrical interfaces have been improved with the inclusion of the CAN interface, which enables a faster and reliable communication between the heater and diagnostics, and also between the heater and the control elements. Due to integration with CAN, the Airtronic 2 heater can be installed in complex configurations with multiple heaters or with multiple controllers. Beginning with the Airtronic 2 heaters, there is a new naming convention to designate all new generation heaters. The first letter will indicate the heater type. The letter A is used for all Airtronic heaters, including the Airtronic 2 heater. The next letter indicates the heat output class. The Airtronic 2 heaters are only available in the small and medium heat output classes. The number after the heat output class indicates the heater generation. The number 2 is used for the second generation Airtronic 2 heater. This is followed by the fuel type designation of the heater. The letter D designates the diesel version of the heater. The letter B will designate the gasoline version of the heater. The letter B is for benzene, which is a component of gasoline. The number that follows the fuel type will indicate the maximum heat output of the heater. For example, the Airtronic 2 heater with an actual maximum heat output of 2.2 kilowatt is rounded up and designated as a 2 kilowatt heater. The letter L, which stands for long life, indicates the version of the heater. The L version of the heater is widely used for most common applications. The letter R is used to indicate the recreational version of the heater and is intended for use in RV applications. Next is the voltage rating for the heater. The diesel versions of the Airtronic 2 heaters are available in both 12 volts and 24 volts. However, the gasoline versions of the heater are only available in 12 volts. The heater designation ends with the marketing appendix, which indicates the category of applications that the heater is generally intended for. The Airtronic 2 heater was released in 6 models based on heating class, fuel type, version, and voltage rating. In the small heating class, there are 2 models of the commercial version of the heater, with the fuel type diesel and in 12 volts and 24 volts. In the medium heating class, there are 4 models. 2 models of the commercial version of the heater, with the fuel type diesel and in 12 volts and 24 volts. 1 model of the commercial version of the heater, with the fuel type gasoline in 12 volts. And finally, 1 model of the recreational version of the heater, with the fuel type diesel in 12 volts. It should be noted that the recreational version of the Airtronic 2 heater is only intended to be used on installations that require a higher duct rating. This version of the heater has a higher power consumption than a commercial version of the heater with the exact same heat output. All of the core parts of the Airtronic 2 heater have been redesigned. These parts are the blower fan assembly, the ECU, the combination sensors, and the fuel metering pump. Some of the other parts of the heater have partial design changes. These parts include the heat exchanger and the glow pin. Although the design concept remains the same, the heat exchanger of the Airtronic 2 heater has been slightly modified to accommodate the new style combination sensors. The heat exchanger has a new part number and is not interchangeable with that of the previous generation heater. The design of the flame tube assembly with combustion chamber has not changed and is the same as the part used in the first generation Airtronic heater. The blower motor assembly is of a totally new design. It has a brushless motor that allows for extended minimum service life of up to 5,000 hours. As mentioned before, the blower fan is built with multi-component materials to lower the operational noise. The blower motor assembly has 3 built-in metal posts that connects directly to the ECU without requiring a harness, terminals, or connectors. This eliminates potential failure points and increases reliability of the heater. The function of the blower motor assembly still remains the same as before. The combustion air wheel will draw in the combustion air, and the larger blower fan will recirculate the air drawn in from the vehicle over the heat exchanger for processing. The combination sensor assembly has been redesigned. It is installed on 2 posts that are part of the heat exchanger casting and is locked in place securely by folding the tabs on the mounting strap of the combination sensor. The combination sensor assembly has the same function as before. The flame sensor will detect the temperature rise of the heat exchanger, and the overheat sensor will serve as overheat protection. A special plastic tool is included with every spare part to bend the locking tabs to the correct angle and securely hold it in place. The basic design of the Airtronic 2 glow pin is the same as before, except now it has terminals instead of an electrical connector. The glow pin ignites the fuel-air mixture. The Airtronic 2 glow pin screen is exactly the same part as used in the previous generation heater. Removing and replacing the glow pin screen is part of the annual recommended maintenance. The glow pin will have to be first removed to gain access to the glow pin screen. The glow pin can be removed without unpinning the terminals. To do this, disconnect the internal harness from the ECU and also disconnect it from the main heater harness. Loosen the glow pin and then rotate the internal harness with the glow pin, making sure that the glow pin cables are not being twisted. The ECU has been designed, developed, and is produced in-house by our own Eberspaecher Automotive Controls division. The advantage is that future revisions or updates can be implemented far more quickly without having to rely on third-party vendors and while maintaining the quality and price. The ECU comes with a built-in sensor, and it is the default ambient air sensor for the heater. The heater harness can be fitted with an external ambient air sensor, but it does not automatically become the default sensor. The ECU will have to be manually switched over to the external sensor using the EasyScan diagnostics tool. The fuel metering pump functions the same way as before and operates based on pulse signal voltage from the ECU. For each pulse signal voltage received, the piston in the fuel pump moves back and forth and supplies fuel to the heater. Like the first generation heater, the fuel metering pump of the Airtronic 2 heater also has a fuel filter located on the inlet side. Removing and replacing this fuel filter annually is part of the maintenance and service recommendations. The fuel metering pump redesign includes changes in the material and the dimensions of the damping element, which reduces the operational noise. The piston of the fuel pump is braked electrically to make the fuel pump a lot quieter, especially when it is filled with fuel. Just like the previous generation heaters, the fuel metering pump has to be installed at the preferred angles. There are limits to the length of fuel lines from the fuel pump to the heater and to the fuel tanks. Refer to the heater's technical description manuals or complete installation guidelines. The operation and function of the Airtronic 2 heater is very similar to the first generation heater. Some of the parameters have been adjusted, but the overall basic principle is the same. There are several phases in the operation of an Airtronic 2 heater. When the heater is switched on, the system's test phase will be executed first and all operational parts will be tested internally. If the parts test is successful, the startup and ignition phase is executed next. In this phase, the glow pin will be activated and preheated. The blower fan will be activated at a low speed and then ramped up gradually. After a time delay, the fuel metering pump will be activated and the fuel will enter the glow pin chamber through the glow pin screen. The vaporized fuel mixes with the combustion air, and this mixture will be ignited by the preheated glow pin. When the fuel begins to burn independently, the temperature of the heat exchanger will rise. This will be measured by the flame sensor, and the ECU will be able to detect the flame. The glow pin will be switched off shortly afterwards. Like the first generation heaters, if the Airtronic 2 heater is not successful in the first attempt, it will automatically make a repeat start attempt. But if the 2 consecutive start attempts are not successful, the heater will generate an active fault code and go through a cool down cycle before switching off. If the ECU successfully detects a flame in any start attempt, it will switch to the regulation phase and control the heat output. In this phase, the heat output of the Airtronic 2 heater will be varied based on the ambient temperature and the required set point temperature. The default sensor of the heater will be used to monitor the ambient temperature. Another operational phase of the Airtronic 2 heater is the standby mode. If the delta T between the ambient temperature being monitored and the required set point temperature is 3 °Kelvin or more, the heater will switch off into standby mode. Later, when the delta T between the ambient temperature and the required set point temperature drops to minus 0.5 °Kelvin or less, the heater will automatically restart. The final phase of the heater is the shutdown and cool down process. In the cool down process, the blower fan will operate at a preset speed for approximately 4 minutes. During this time, the fuel pump will remain switched off, but the glow pin will be re-energized for approximately 40 seconds to burn off any residual fuel. If the power supply to the heater is disconnected during this phase, the heater will be forced to shut down immediately without cooling down. This can damage components within, especially the blower fan assembly. When compared, the functional difference between the first generation and the second generation Airtronic heater is clearly visible. These two graphs show the orange line for the first generation Airtronic heater and the blue line for the second generation Airtronic 2 heater. The switch-off temperature is much closer to the set point as compared to the previous generation heater. The first generation Airtronic heater has a delta T of 5 °Kelvin, whereas the second generation Airtronic 2 heater has a lower delta T of 3 °Kelvin. This means that during operation, the second generation Airtronic 2 heater will shut down a whole lot quicker after it reaches the required set point temperature. The graph of the heat output shows that the new second generation Airtronic 2 heater has a smoother curve versus the first generation heater. Also, the second generation Airtronic 2 heater restarts from the standby mode with a heat output of 27%, which is far less than the previous generation heater. The variable or stepless heat output of the Airtronic 2 heater results in a much better optimum temperature being maintained without having very wide swings in the heating output. Due to the heat output being adjusted in smaller steps, the operational noise of the Airtronic 2 heater is much more subdued and considerably quieter. This Airtronic 2 heater modular harness has been specifically designed and configured for the North American customers in the aftermarket. This harness is more reliable, much longer in length, modular in design, and easier to install. This harness is different from the original European-style factory harness, which were initially shipped out with the first batch of heaters. All of the Airtronic 2 installation kits have the standardized North American modular harnesses. The Airtronic 2 harness has a 10-pin connector on one end that connects to the heater. The first branch of the harness is shorter in length and has a 3-amp controller fuse pre-assembled on the end. The next branch is the battery harness and comes attached with bagged parts, which includes the ring terminals, fuse holders, terminals, etc. The third branch of the harness is the fuel pump harness. It is shorter in length and it comes pre-assembled with an older style male connector. A fuel pump adapter harness is also included with the main heater harness. It comes with a newer style fuel pump connector pre-assembled on one end. It also has bagged parts attached, which contains an older style female connector, terminals, and weather seals. The fuel pump adapter harness is connected to the fuel metering pump and routed towards the heater and cut to length. The older style female connector is assembled onto the loose end of the fuel pump adapter harness. This is then connected to the matching style male connector on the fuel pump harness. The fourth branch of the harness is a short CAN controller harness. It has a gray 4-pin male and female Deutsch connector assembled on the end. The female Deutsch connector has a 120 ohm resistor pre-installed. This resistor is one of the 2 CAN termination resistors required in the entire heater main harness. This end of the CAN controller harness connects to the Easy Start Pro adapter harness. During installation, the female Deutsch connector with the 120 ohm termination resistor is moved to the outer end of the Easy Start Pro adapter harness. The fifth branch of the harness is the diagnostics harness, and it has a 4-pin black male and female connector that will be used to connect to the Easy Scan adapter. There is a 10 kilo ohm resistor pre-installed on the female connector. This resistor is installed to suppress any electrical interferences from adjoining equipment in the vehicle that may affect CAN communication in the heater. There is a 120 ohm termination resistor permanently embedded in the diagnostic harness and clearly marked with a yellow label, "Do not bend." The sixth branch of the harness is the analog harness. This is provided in the modular harness assembly to allow customers to install analog controllers, connect to external sensors, or for the use of codable output signals. To connect the Easy Start Pro controller to the CAN controller branch of the heater harness, an additional adapter harness is required. This can be ordered separately, or a full installation kit that includes the Easy Start Pro controller and the adapter harness can also be ordered. The Easy Start Pro adapter harness comes attached with a square 4-pin connector and a gray male Deutsch connector on one end. It also has bagged parts included, which contains terminals, a locking plug, and a female Deutsch connector. The square connector is plugged into the Easy Start Pro controller. The loose end of the Easy Start Pro adapter harness is routed to the heater scan controller harness and cut to length. The terminals and the female Deutsch connector are attached and assembled to the adapter harness. This end is then attached to the male Deutsch connector on the CAN controller harness. The connector with the 120 ohm termination resistor is removed from the CAN controller harness and plugged into the male Deutsch connector on the Easy Start Pro adapter harness. The second generation Airtronic 2 heater can be operated via CAN LIN or analog controllers. Multiple controller types can be used simultaneously with one heater, or multiple heaters can be operated via a single CAN controller. CAN-based Easy Start Pro controller would be the most preferred option in most applications. Synchronization between multiple CAN-based controllers is possible, and the heater or heaters in the application can be operated via either of the controllers. The 12-volt second-generation Airtronic 2 heaters with the most current version of the ECU software can also be operated with the LIN interface. LIN-based controllers like the Easy Start Timer or the Easy Start Select can be used to control the heater operation over the blue-white wire. Synchronization is also possible between multiple LIN-based controllers by designating one controller as the master and the second as a slave. The third option is to use an analog controller and operate the heater with an S+ signal. The S+ signal is the 12-volt or the 24-volt input from the controller. This option allows analog controllers like the Digimax or the mini controller to be used with the Airtronic 2 heater. However, limitations will apply, like the non-availability of diagnostic functions, timer functions, non-use of external temperature sensors, etc. The Airtronic 2 heater can be operated with more than one controller and with different controller types. However, in this kind of a setup, some controller types will have a higher priority over others. For example, a CAN-based Easy Start Pro controller will have higher priority over a LIN-based Easy Start Timer, and likewise, the Easy Start Timer will have higher priority over the analog Digimax controller. The Airtronic 2 heater has a built-in sensor located in the ECU, and it is the default ambient air sensor for operational control. However, an external remote sensor can be connected to the heater harness and used for operational control. But this is only possible when the heater is operated using a CAN-based controller like the Easy Start Pro. The external sensor is not automatically set as a default ambient air sensor. The installer will have to manually set it with the Easy Scan diagnostic tool. An external sensor cannot be used when the heater is being operated with an analog controller like the Digimax or the mini controller. The Airtronic 2 heater has a 10-pin connector to connect to the main harness. Pins 1 and 3 are used for the CAN high and CAN low connections. The 120 ohms resistors are placed in parallel across these two CAN bus wires. The effective resistance across the CAN high and CAN low wires should always read approximately 60 ohms. This would be a good way to detect broken, missing, or defective termination resistors. Pins 2 and 4 are used to connect power and ground to the heater. Pins 5 and 6 have dual purposes. If the Easy Start Pro controller is being used, then pins 5 and 6 could be used for an external sensor on the heater side. But when an analog controller like the Digimax is being used, then pins 5 and 6 are reserved for set point temperature connections. Pin 7 is used to send pulse signals to the fuel metering pump. Pin 8 is for LIN communication between the Easy Start Timer or the Easy Start Select controller and the 12-volt Airtronic 2 heaters. Pin 9 is a codable output and can be switched manually to any of the 4 possible options with the Easy Scan diagnostic tool. The default is set to option 4, which will generate a blink code in the event of a heater fault. Connecting a LED to the white-red wire from pin 9 will allow the diagnostic blink codes to be read. The other 3 options can be used to generate an output signal from pin 9 under select conditions. This would include when the heater operates in heating or ventilation mode, or when the heater operates in ventilation mode and the ambient temperature does not drop below 10 degrees Kelvin or more, or when the heat output does not drop more than 10% of the maximum output. Pin 10 is used to receive an input signal, either 12 volts or 24 volts from the analog controller, and is used to activate the heater. This activation signal bypasses the CAN communication channel on the heater. The Airtronic 2 heater manual will outline the different blink codes available with their description and instructions. Blink codes are not as comprehensive as the regular diagnostic fault codes. Blink codes may be used when the Airtronic 2 heater is being operated by an analog controller or access to Easy Scan diagnostic tool is not available. In the first generation heater, the ECU, the glow pin screen, and the combination sensor could be removed without removing the entire heater. In case of the Airtronic 2 heater, the ECU, the glow pin, and the glow pin screen can also be removed without having to remove the entire heater. However, to remove and replace the combination sensor, the heater will have to be removed first. Before proceeding to remove the heater, always test and confirm if the combination sensor is defective or damaged and requires to be replaced. The new replacement part will include a special tool to ensure a secure mounting on the heat exchanger. The fault codes in the Airtronic 2 heater are now stored in standardized automotive format, which begins with the letter P, followed by a 6-digit number. However, the description and the troubleshooting instructions are identical to similar 2-digit fault codes from the previous generation heaters. The Airtronic 2 heater ECU can store up to 10 fault codes in the stored error memory. The active error memory can also display up to 10 fault codes. In addition, further information about fault codes and heater status is also stored in the ECU memory. The Airtronic 2 ECU is equipped with a mirror error memory that can retain up to 10 fault codes. A complete list of these fault codes is available in the troubleshooting and repair manuals for the Airtronic 2 heater and can be downloaded from the Eberspaecher partner portal. An ECU lockout fault code will be triggered after 10 consecutive failure to start faults or after 10 consecutive overheat faults. The ECU lockout codes are P00012B for frequent failure to start faults and P00011B for the frequent overheat faults. The preferred way to unlock the heater would be to reset the lockout counter back to 0 using the Easy Scan diagnostic tool. This will retain all the fault codes and the fault code data, which could be used to analyze heater issues in the future. The Airtronic 2 ECU could also be unlocked by clearing the fault code memory, either by using the Easy Scan diagnostic tool or by using the Easy Start Pro controller. However, this method will delete all the fault codes and any additional data stored in the ECU memory. The mirror memory cannot be deleted and will be retained. If the Airtronic 2 heater is locked out due to frequent overheating faults, then it is possible to unlock the ECU without a diagnostic tool. The annual maintenance and service recommendations are very similar to what is recommended on the first generation Airtronic heater. The most important recommendation is to operate the heater with maximum set point temperature once every month and for a minimum 15 minutes each month, all year long. A complete visual inspection of the heater and installation must be done once every year, preferably before the heating season. It is recommended to remove and replace the glow pin screen every year or after every 1,000 hours of operation. This process allows to clean up any carbon residue that may be blocking the ventilation hole. It is recommended to replace the filter on the inlet side of the fuel metering pump on an annual basis. A choked fuel pump filter can affect the heater startup process and cause excessive smoke and failure to start conditions. It is also recommended to verify the controller settings every year before the heating season. Altered controller parameters may affect the heater operation. Finally, it is also recommended to review the fault codes in the heater memory and take proactive steps to fix the issues before the heating season begins. The Airtronic 2 heater installation kits are listed in the product catalog. Commonly used installation kits will be marked as recommended. Some installation kits may not include the fuel pickup tube and the controller. It is important to review the installation kit contents and order any parts not included in it. The current version of the product catalog is available on the Eberspaecher partner portal. This brings us to the end of this video on the second generation Airtronic 2 heater. Please contact us if you need further information or training. You can also visit our website and the partner portal for more information. Thank you for watching.